11.4 Volumes of prisms and cylinders. Well, volumes tend to be a little more forgiving than surface area, so let's see how we do here. We're going to be able to find the volume of a prism or a cylinder when we know its height. Now we need to indicate that's the height of the prism or the cylinder from base to base, and the area of its base. Don't forget that is big B. And we can use any area formula for that depending on the shape of the polygon. A little bit of vocabulary here. Volume is the space that a figure occupies. You probably understand volume. We live in a 3D world. We use cubic units. All volume is cubed, just like all area is squared. All volume is cubed. So cubic inches, cubic feet, centimeters cubed would be another way to say that. Okay, so when we started, we said that a point is a dimensionless, just dimensionless. Doesn't have length, width, depth, nothing. If we put a whole bunch of points together, we get a line. Okay, and now we have a length. And if we put a whole bunch of lines, we stack a whole bunch of lines up, we eventually end up with an area. And we take that length, which becomes our base, and we multiply that by how high we stack those lines. This gives us area. Well, if we have the area of this base and we stack a whole bunch of areas up, that turns into a volume. So this is the area of our base, big B, with all of our lines stacked up here. And then we take that and we stack those lines some height and we get volume. Now, if we look at our two stacks of paper here, we see that both stacks have the same number of sheets, and you recognize that the one on the right here is going to be a right prism, and the one on the left is an oblique prism. Okay. Now, we only dealt with right prisms when we were doing surface area because they were much nicer. But think about this. We have a nice, neat stack of papers, and we tilt them over. The thing about these is that they have the same height, whether we measure it from here to here or from here to here. Height is just perpendicular to the base. They both have the same height, and therefore they're both going to have the same volume because our sheet of paper, each sheet of paper has the same area. Our base is going to have the same area. Now what this is Cavalier's principle, and it says that if two space figures, two 3D figures, space just means we're in 3 dimensions here, have the same height and the same cross-sectional area, that just means the same base, right? The same base area at every level, then they are going to have the same volume. So if we look at our 3 figures here, we have a stack of papers, and they are a 3 by 2 rectangle here that makes the base. Same base, we're taking a cross section, that's just cutting our loaf of bread. You remember back from 11.1 when we sliced planes through our figures. And if we take that stack of paper and we tilt it, we still have a 3 by 2 parallelogram here. Now the same is true, we're going to have the same volume if our bases have the same area. So look at our triangle here. If it has the height of 2, what's going to happen to its base? Well, we know areas of triangles are half of the square. So check it out right here. This base length becomes 6 centimeters instead of 3. We have to double the base length. So that should not surprise us. All 3 of these figures have the same volume. So that's kind of fun with volume. All right, let's get to our first theorem here. How do we find the volume of a prism? Well, the volume of a prism is the product of the area of the base, and you should get used to saying all of these words. We have a lot of bases and heights and everything going on, so you need to know which is which. Area of the base and the height of the prism. So we have our formula right here. Volume is area of the base times the height of the prism. All we have to do is identify the base. You know that a prism's base are the two parallel congruent sides. The bases are parallel and congruent faces. So we find our bases, and then this right here, perpendicular distance between the two bases, is the height of the prism. Make sure you are using the correct measurement there. So once again, we are going to have to find the area of the base separately and then multiply it by the height of the prism. The area of the base depends on its shape, and we have plenty of formulas to work all that out. So let's look at our first example here. We are given a nice rectangular prism. We want the volume. Well, we locate our base. Since it's a rectangular prism, it's anywhere. We will call this B of our square. Then this would be H of our square, base times height, and then we multiply that by the height of our prism, and we come out with 4,800 cubic centimeters. Okay, why don't you pause the video and try the next example. Okay, we were asked to find the volume of the rectangular prism at the right, so I identified my base, and I want to find the area of my base. So if I'm talking strictly about my base here, I've shaded it in green. The base length is 5, the height is 3. This is only of my base polygon here. So I find the area of the base, 5 times 3 is 15, and then the height of my prism, I've labeled it height prism so I keep it straight, that's 4 feet. Multiply 15 times 4, I get 60 feet cubed. Don't forget, volume is cubed. And then it asks us, suppose that that same prism is turned so that we consider the base to be the 4 foot by 5 foot side. Well, that's like either flipping it over on its back or its front, or just considering to have our base here. Now we know no matter which way we turn our stack of papers, the volume does not change, so the volume is going to be the same. If we work it out, now our front side here is the base, and that makes the height of our prism the 3 foot side. 5 times 4 is 20, that's the area of the base. We multiply that by the height of the prism, which is 3, and of course we are going to get the same answer, 60 feet cubed. So those are pretty easy. Volume is pretty easy compared to surface area. Not necessarily easy, just less work. All right, finding the volume of a triangular prism. Well, it's the same thing. We need the area of the base and the height of the prism. So the first thing I'm going to do is find my bases and my triangles here, which means that this is the height of the prism. It connects the bases perpendicular to both bases. And so now I have this triangle. We know what triangles do, right? So we see that we have an 8 by 8 by 8 inch triangle. That means we have an equilateral, which tells us it's 60 degrees. So this is isosceles regardless, which means we can cut it down and make these two, cut the base, bisect the base. But since we know that this full length is 8 inches, I know that this right here is 4. because it's equilateral, we have a 30, 60, 90, and that should ring bells with you that we have 30, 60, 90, which means we have x, 2x, and x root 3, which means this is going to be x root 3 right here, and we know that x is 4, so we know the height of our triangle is going to be 4 square root 3, and the base of our triangle, that's height of our triangle, and the base of our triangle is going to be 8, right? Because the whole thing across was 8. So we have a base and a height for our triangle. We're going to leave it in simplest radical form. We deal with those irrational numbers at the end. And then when we want to find the volume, it's simply our base area right here times the height of our prism. Remember, we labeled that earlier. We get 160 square root 3. We could write inches cubed on that, or we can put all of that into our calculator and round it to the nearest whatever decimal place we like. All right, pause the video and try the next example. Okay, we were asked, what is the volume of the triangular prism at the right? That tells us that the bases are the triangles. We can just look and see that, the two congruent parallel faces. So we know we need to find the area of the base. Area of a triangle is 1/2 base times height. We redraw our triangle here and label it, and we label the base of the triangle as 6, the height of the triangle is 10, and that tells us that the height of our prism is right here connecting our two bases is 5. We substitute into our formulas. The area of the base is 30 meters squared. We multiply that by the height of the prism and get 150 meters cubed. The second question says, what happens if the height of the prism is doubled? How does it affect the volume? Well, it's simply going to double the volume because we are multiplying the area of the base times the height. So if we try some numbers here, we use our area of our base from the previous problem. It's 30 meters squared, and we multiply it by double the height, so times 10, we get 300 meters cubed, which is double the volume we got before. It's just stacking another set of papers on top, simply doubling the volume. You make it twice as high, you double the volume. We essentially double our stack of papers. Okay. Oh, look, cylinders. Just like cylinders got easier with surface area, those special circles, they get easier with volume as well. Now, if you remember our formula for volume of a prism, and this is simply a circular prism, was area of the base times the height of the prism. Well, what shape is the base? Well, that's simply the area of a circle, which is pi r squared. If we put that in, the volume of a cylinder is the product of the area of the base and the height of the cylinder. It's exactly the same, but our formula is special. Volume equals pi r squared h is true for every cylinder you are going to run into. So let's look at our first example here. We want to know the volume of the cylinder in terms of pi. Well, what information do we need? We need the radius and the height of the prism. So we are told the radius is 3 centimeters, the height of the prism is 8 centimeters, and we shove that into our formula. we get pi times 3 squared times 8. Make sure you do the 3 squared. We leave it in terms of pi. The volume is 72 pi centimeters cubed. If we want it as a decimal, we just put it in our calculator. All right, pause the video and try the next example. All right, these are pretty easy. What is the volume of the cylinder? So in terms of, that should say pi. So we know the radius is 1 meter, because we were given the diameter. Change colors. We were given the diameter equals 2 meters, so we know the radius is just 1 meter. And we know the height of our prism, measured perpendicular here between the bases. Even though this is an oblique prism, it still works for us. So our height is 3 meters, and we put that into our formula. We get 3 pi meters cubed for the volume of our cylinder. The next question says, what if the radius of the cylinder is halved? How does that affect the volume? Well, it's going to be 1/4, because in our formula, radius is squared. So if we divide our radius by 2, if you remember your rules for exponents, everything in there gets squared. It's radius over 4. Radius squared over 4. Your radius squared over 4, that's 1/4 of the volume. So if we look here and do a half a meter for our radius instead of 1 meter, and we get 3/4 pi meters cubed, which is dividing by 4 for the previous one. All right, cylinders, they're awesome. Composite figures. Well, this doesn't have a theorem to go with it, but this is in the family of our addition postulates. How do we get 2 volumes? How do we get the volume of one weird shaped figure? Well, we break it up into as many normal figures as we can. So we see this fish tank here, and I see that I can break this up into a nice rectangular prism and a cylinder, a half a cylinder, but it's still a cylinder. And so if I'm looking at this, I know this measurement over here is 24, so I know this measurement is 24. And this is a diameter. If you think of this as a whole circle here, that's a diameter, which means my radius is 12. So if I know this entire length is 48, I know that from here to here is 12, because that radius goes everywhere, so this is going to be 36 inches. So I break it up into 2 separate figures. I find the volume of my rectangular prism and the volume of my cylinder, and I do 1/2 of the volume of my cylinder, because that's all there is. Add them together, and we get a volume of the aquarium. How much water do we need to pour into it? All right, pause the video and try the last example. All right, so we wanted to know the volume of our lunchbox. How much food can we fit in, and we want to round to the nearest 1/10 of an inch. So what I know is that this total volume is the volume of this rectangular prism down here on the bottom, and then I have a half cylinder up on the top. So I'm going to do my prism first, and I just did a quick little sketch here, identified my base, and labeled my measurements. I know that the base of my base, the base of my rectangle here is 10. The height of my rectangle here is 6. That allows me to find the area of the base, and then I multiply that by the height of the prism, which I also labeled very clearly, and I get 360 inches cubed. And then I move on to my cylinder. I know that the volume of the cylinder is pi r squared h. I know my radius is 3, and the height of my cylinder, which I labeled very clearly, is 10, because that is this length that goes across the front of my lunchbox here, which is the same as the length on the rectangular prism. So I just put my numbers in, and I get 90 pi inches cubed. But I only want half of that, so the volume of my half cylinder is 45 pi inches cubed. Now I'm going to put those in. My total volume, get an extra 0 here. My total volume, get rid of that, so much better. My total volume is 360 plus 45 pi inches cubed. That would be in terms of pi. And then if we want a decimal, which we're asked for, we put it into our calculator. This comes out to be a nice decimal there, and we get 501.4 inches cubed. So both of these answers say exactly the same thing. This one is in terms of pi, and this one is rounded to the nearest tenth. So volume is really quite simple as long as you are labeling your diagrams. Again, shade in the side that you're looking at. It will help you see, it will help it stand out so that you can see the measurements. Label your base and height of your base that you're finding the area of separately from the height of the prism or the height of the cylinder, so that you can keep those straight. You don't want to mix those up. Write your formulas and substitute in. Make sure you write out your formulas completely. The best way to make these simple is to do every step. There's going to be 2 or 3 steps to all of these problems. Do them separately, and everything will come together nicely.